Okay, so as I said in the previous video, I really want to talk about how we could use the cross product in the third dimension. So, I'm going to talk through some things and point out some things, and we're going to kind of get to the formula here. To begin with, imagine a prism with a parallelogram as its base. Okay, the volume then of that parallelogram, or of that prism, would be the area of the base. I'm going to write A sub B, area of the base multiplied by the height. Okay. Now we already said there are lots of ways to find the area, but nice easy way apparently is to find the magnitude of, in this case, A cross B times height. Okay? Now, that's a prism, but it also works when you tip your prism sideways. Okay? And this is what's called a parallelepiped. It's got a parallelogram for every single face. You can see every single face. It looked like a prism that almost got tipped over a little bit. So in this prism, similar to the idea of a parallelogram, you really need to know the height. Okay? And we could take then the area of our base, which we got by using cross product, and multiply that by the height. So the question is, well, how do you find the height? Well, we need to know the angle, right? The angle at which we were tipping, because that obviously will affect the height. It'll affect the volume. And then you could say, well, if I did the cosine of that angle, would equal the height divided by the hypotenuse, that. So the height is equal to this. And you can see that right there in my picture. Now you got to think, okay, how am I going to take this height and multiply it by this cross product? Well, you'll notice cosine. You'll notice this magnitude. This is very, very similar to the dot product. Essentially, you're going to cross A and B, and then you are going to dot it with C and find the magnitude of that. Okay? So it is A cross B and then dotted with C. Now, I'm going to show you how this formula works, but I just wanted, and we're going to do an example on the next slide, but I just want to point out here that this is a new vector, and then you dot it, so now you have a scalar. So when I say it's the magnitude, it really is just going to be the positive version of the answer. So if you got a negative 50, the magnitude is 50, because all we get out in the end is a scalar, because we had dotted, right? This returns a vector, but then we dotted it, so that creates a scalar. Now, one thing that people are nervous about when they first see this is, does the order matter? And the answer, thankfully, is no. Because every single face is a parallelogram. So if you think about a prism where every face is the same kind of shape, it won't really matter what we make our base. So we could certainly do B cross C and then use A to find our height. And obviously A is not the height, but we could find it using A. We could do A cross C dealing with this, and then use B as kind of our height. So it doesn't matter. This is one of the nice things about this. Okay, let's do an example. Okay, so we're going to find a volume of a parallelepiped generated by these vectors. Okay, so here to me is the easiest way to do it. Start kind of like we were before, but instead of I, J, K, just write A as your top line. Again, the order doesn't matter. I'm just going in the order they were presented. Okay, like that. Do the same thing that we had been doing with cross product, but again, you see that we don't have an I and a J and a K. I'm going to write the -2 in place of I, the 3 in place of J, and the 1 in place of K. Let me do that, and then let's explain why this is working the way it is. But I think it'll be easier if I have the numbers written down. So -2 instead of I, and then 12 minus 0. Well, minus now 3 instead of J. And I've got 0 minus 0. Well, that's easy. Plus 1 in place of K. There we go. And 0 minus -4. Let's write 0 minus -4. Okay, so I want you to just think about dot product and what it does and why this is going to work and do everything we want in one step. Okay. When we do this determinant, and usually we said I times this, we're figuring out how our forces are working, the Y and Z forces on X. Right? That's what the cross product does, sees how these opposite forces are acting. So we say, well, we figure that out. That becomes our X component in our new vector. Well, with the dot product, you just multiply the X's together. That's what we just did. We took the X of A and multiply it by the X of our new vector that we calculated with this. Then we did the Y of our A vector multiplied by our new vector that we got by calculating that. And the same, we took our Z part by our new Z part that we got by doing the cross product. So this works great to do it all at once. All right, so we got -2 times 12 minus 0 plus 4 for an answer of -20. But we need to know not just the answer, but the magnitude of the answer. The magnitude of -20 is 20. And this is the volume of the parallelepiped generated with those 3 vectors. Now, the last question I just want to hint at is, and something that'll come up, how do we know if 3 vectors are what we call coplanar? Meaning they all lie in the same plane. And the answer is if what we just did gives an answer of 0. If 3 vectors generate a parallelepiped with a volume of 0, that means there really was no height. So the vectors must all be in the same plane together, and they didn't really generate a parallelepiped at all. So that will come up, how we know the 3 vectors are coplanar. This is a nice way to check